Alright, so let's quickly look at these 5 questions on mapping and function. So for question 1, we have if f of x is equal to x squared plus 3x minus 5 and g of x is equal to 4x plus 5, we have to find f g of x. Now looking at the options, we have numbers, right? So meaning that there's supposed to be something as the value of x, but it was omitted in the question. But first of all, let's find fg of x, then we can just put any value, then we can solve. So now if you want to find fg of, what this means is that you are putting g of x as your value of x, right? Now if you have something like this, let's say you have f of x to be 2x plus 1, right? And you are asked to find f of 1, it is just going to be wherever you see x you put 1. So you have 2 times 1 plus 1, and this is going to be 2 plus 1, which is 3, right? But for this case now, where you have f in bracket g of x, it means that g of x is going to take the value of x, right? So wherever you see x in f of x, you are going to put g of x, right? So let me write, so this is how that looks like. Let me clean this. Alright, so here we are saying f of x is equal to x squared plus 3x minus 5, and g of x is equal to 4x plus 5, right? So if we are saying f g of x, we are going to be putting the value of gx as x, right? So wherever we see f of x, whenever we see x in f of x, we are going to put gx, right? So x squared, we are going to put gx, which is 4x plus 5 square plus 3 4x plus 5 minus 5, right? So this is going to be equal to 4x squared, 4x, that will be 4x plus 5 multiplied by 4x plus 5 plus 3 4x plus 5 minus 5. So this is going to be 4x times 4x, that will give us 16x squared. 4x times 5, that will give us plus 20x. 5 times 4x will give us plus 20x. Then we have 5 times 5, that will give us plus 25. Then we move here, we have 3 times 4, that will give us 12x plus 15. Then we have minus 5. So this is going to be equal to 16x squared. Then we have here, we have 40x plus this one, that will give us 52x. Then we have 25 plus 15, which is 40 minus 5, that will give us plus 35, right? So there's supposed to be a number here, right? So if there was a number here, what we're just going to do now is that we're going to put that number, we'll just put it here, and then we get our answer, and it's going to be one of these options, right? But there's another way we could do it. If there was a number here, what we will first do, so let's say we have like f, let me clean this. All right, just quickly write this down. Let me clean it so I explain if we have add a number there. So if we have a number, if we had a number, something like f g of 1, what we're going to do is that we're going to find g of 1 first. So this is going to be 4, then g of 1, put 1 here plus 5, then this is going to be 4 plus 5 equal to 9. So this one here is going to change to f of 9, because f g of 1 is 9. So this is going to change f of 9, and then we'll just put 9 here. So we'll be having f of 9 to be equal to 9 squared plus 3 times 9 minus 5, and this is going to be 81 plus 27 minus 5. So basically that's how to do it. So let's go to number 2. So number 2 says f of x is equal to L ln x. It's an example of dash function, right? So we have f of x is equal to ln x. It's an example of dash function. We have transcendental function, we have injective, we have onto and into. So let me explain what transcendental function is, right? So a transcendental function is a function that is not expressed by algebraic means. It is not expressed by algebraic means. So something like this: cos x, sin x, ln x, e raised to the power of x, exponential functions, trig functions, right? They are all transcendental because they are not expressed in algebraic means. What I mean by algebraic means is something like this. 4x plus 5, 2x plus 5, 3x squared minus 5x plus 2. All these ones here, they are not transcendental, but these ones that are not expressed in algebraic means, they are transcendental functions, right? They are transcendental functions. So alright, so now that means that f of x ln x is a transcendental function. So let me just quickly explain what injective functions are, right? So injective functions are functions that are one to one, right? It means that one element of A has just one image in B. That's what it means, right? So if we have something like let me see x plus 1 now. If I have something like x plus 1 and I take, let's say the this thing of A is 1, 2 and 3. If I put 1 here, I have 1 plus 1, it's going to give me 2, right? If I put minus 1 plus 1, it's going to give me 0. So it means that no two image in A has the same pre-image in B. So once it is 1 to 1, then it is injective. Then we have onto. Right? We have onto functions and then we have into functions. Now for onto functions, we have every element of B is the image of at least one element in A. So something like this now. If we have, sorry, let me change this back to pen. If we have A and we have B, we are saying that every element of B is the image of at least one element in A. So that means if we have A, B, C, and we have 1, 2, 3, there must be an image in A. So this one has an image, this one has an image. It does not matter whether it's many to one, but as long as this one, B, has an image in A, then it is onto, right? Then let's go to into. So now for into is when some elements in B are not output of the function, right? When we have A is 1, 2, 3. Into is like the opposite of onto. A, B, C, right? If we have something like this, this is telling us that this is into, because not all the elements of B have a image in A. So when this happens, it is into. But for onto, when all the elements of B have an image in A, then it is onto. But for injective, where we have A and we have B, every element of A has just one element in B, just one. It is 1 to 1, 1 to 1, 1 to 1. It's not compulsory that it is exactly like this. This one can be here, but it is 1 to 1. All right, 1 to 1 is injective. This one can be many to 1, 1 to many, but every element of B must have an image in A. That's what onto is. But for into, every element of B must not have an image in A. That's for into. Alright, so let's go to question 3 now. So let's go to question 3. So question 3 says f of x is equal to 2x plus 1. So we should find f of minus x. This one is very simple. It just means that whenever we have x in f of x, we put minus x, right? So let's solve. So f of minus x is equal to 2 open bracket minus x plus 1. So we have minus 2x plus 1. Chicken, and that's your answer. So let's go to question 4 now. Let's go to question 4. So for question 4 now, we have f of x is equal to 2x cubed minus 4. It says we should find f inverse of 12. So to find f inverse of 12, we first have to find f inverse. We are going to say let f of x is equal to y. So we'll be having y is equal to 2x cubed minus 4, right? We are going to make x the solid of the formula. So we have y, this minus 4 will come here. So it will be plus 4 is equals to 2x cubed. Divide both sides by 2. We have x cubed is equal to y plus 4 over 2. Then we have x is equal to the cube root of y plus 4 over 2. And what we are going to do here, because it's inverse, we are going to switch it. So this x will become y, and this y here will become x. So we have the cube root of x plus 4, everything over 2, right? So we're going to change this y back to f of x. So f of x, because here we already said let f of x be y. So this is going to be the cube root of x plus 4 over 2. Here we have find the inverse of 12. Right? Find the inverse of 12. So here we're going to put anywhere we see s, we're going to put 12. So this is f inverse. This is f inverse. Sorry, not just f of x. F of x inverse. Sorry, the y minus 1 is not supposed to be there. Let me clean. Hey. Alright, sorry. So this is going to be f inverse of x is equal to the cube root of x plus 4 over 2. Right? We are looking for f inverse of 12. So let's put 12 as x. So this is going to be equals to the cube root of 12 plus 4 over 2. And this is going to be equal to the cube root of 16 over 2. And it's going to be cube root of 8. And this is going to be equal to 2. Right? The cube root of 8 is 2. So that is for number 4. So let's go to the last question. Let's go to the last question. So now the last question says, which of the following is many to 1? Which of the following is many to 1? What this means is that when we have an image A and we have image B, right? We have A, B, C here. We have 1, 2, 3. They say which one has many to 1? That means this A here can have like 2 of them now. This is many to 1 because there are 2 images in A to 1 image here. Many here to 1 here. That's the meaning of many to 1. So they ask me which one is many to 1. So here option A we have y is equal to x squared minus 2, right? And then B we have x squared plus 2x. C we have x cubed plus 2. And D we have x squared minus 2x, not c squared, sorry, x squared minus c. So now let's try. We're going to be using 2 values of our case study, 1 and minus 1, right? You can decide to pick 2 and minus 2, right? Just the idea is that 2 image, whenever we get a value, whenever we have 2 image in A that gives a corresponding image in B, that means the 2 of them have the same image in B, then that means it is many to 1. Or we are saying that whenever 2 values of x give us the same value of y, then it is many to 1. So let's try for 1 and minus 1 now. We will put it in all of this. So the first one is y equals to x squared. So we have x squared, which is 1 squared minus 2. So y is equals to 1 minus 2 is minus 1. So let's put minus 1 now. That will be minus 1 squared minus 2. This will be 1 minus 2 equals to minus 1. So we can see that we have different values of x, right? But they gave us the same value of y. So which means that we have many values of s gave us 1 value of y. So this is many to 1. And already we can stop solving. But let's check the other options. Let us see whether they are many to 1 or not. Alright, so now for option B, we have y is equal to x squared plus 2x, right? So remember our case study is 1 and minus 1, right? So if we put 1 here, we have 1 plus 2, that's 3. But if we put minus 1 here, we have minus 1 squared plus 2 into bracket of minus 1, right? So this will give us 1 minus 2, which is minus 1. So this is wrong. The second one is x cubed plus 2. We put 1 here, we have 1 plus 2, 3. We put minus 1 here, we have minus 1 cube, which will be minus 1 plus 2 equals to 1. So this is also wrong. And option D as well is going to be wrong. So there's no need to solve it. Our answer is going to be option A, as we have already proved that it is many to 1.